Hi, hello, welcome to the sixth lesson of Unit 2. We're going to talk about writing equations from patterns. So specifically, we're going to be learning about quadratic equations. So during this lesson, you should learn how to write a quadratic equation from a pattern. So if you see a quadratic relationship in a pattern, we'll be able to, after this, write the standard equation for it. Alright, so here's some review. This is stuff that you should have already done. That should be fairly common for you. So linear patterns. So I have a linear pattern here. How would I write the equation? For most things that we do, it's always good to create a table. So on the first pattern, or on the first number in the sequence, we have one block. In the second one we have 3. In the third one we have 5. And in the fourth one we have 7. So there's a couple of things I need in my equation. I need the D, which is common difference. I need f at 0, which is the 0 number in the sequence. Okay, so let's see. D is, what am I doing each time? So I can see that each time I am adding 2 to the sequence. That's my D value in this. Next, I need to find my 0 number in the sequence. Well, if I'm adding 2 each time, I need to find out what my number up here is. So to move upwards, I'm subtracting 2, so 1 minus 2. So we want to go from here to here. We're going to subtract 2. That's going to be a negative 1. So my f at 0 is negative 1. Now I can just plug it into my formula. I can say f of x equals my d value, which is 2, multiplied by x, plus my f at 0, which in this case is a negative 1, so we would just say minus 1. There is my linear equation for this pattern. Alright, an exponential pattern. So the key here is that for exponential I am multiplying or dividing each step in the sequence. So once again, I'm going to create a table. I am going to leave that 0 spot left over because I still need that f at 0. But this time I need my b value, which we think of as the common ratio. Okay, so on the first block, I'm going to need some more space there. The first block I have 1. The second block I have 2. The third block I have 4. The fourth block I have 8. And the fifth block I have 16. Alright, so I can see that I'm not adding by the same number each time, so I know this isn't linear. So then I would check for an exponential, which means I'm multiplying. Well, I multiply by 2 there. 2 times 4, I'm multiplying by 2. 4 times 8, I'm multiplying by 2. 8 times 16, I'm also multiplying by 2. Okay, so what I need here is I need that f at 0 and that b value, which is my common ratio. That's this 2 here. So my common ratio, or my b value, is 2. Now I need that 0. Since as I'm moving down, I'm multiplying by 2, to go upwards, I need to divide by 2. So 1 divided by 2 is going to be 1/2. So now I can write my equation. I can say f of x equals 1/2 multiplied by 2 raised to the x power. And there's my exponential equation. Alright, so let's just do a quick quadratic relationship review of how we would determine that something is a quadratic based on a table or a pattern. Whenever you have a pattern, make a table. It's going to help a lot. Okay, so first you're going to check the input values. So check the input. Make sure they're increasing by 1. It should really say increasing by the same unit. If they're not, extend the table to fill in the missing. So we want to, if they're not, to extend that table. Next, we're going to check for a linear representation. Okay, so that means they have, this is adding slash subtracting. Next, we're going to check if there's a common difference. So we're going to check if they have a quadratic equation by checking for the second difference. Okay. So if there's one common difference, that means that my first common difference is I adding or subtracting by the same number. If it's not, they could have a second difference, and we'll look at that in a little bit. If there's not a common difference at all, check to see if it's a exponential equation, meaning that it has a common ratio. That's when I am multiplying. We can think of it as dividing, but remember that dividing is just multiplying by a fraction. So if the table doesn't satisfy any of these requirements, it does not represent any of the relationships. Okay, so those are the three things we know. We know how to determine if something's linear, we know how to determine if something is exponential, and we know how to determine if something is quadratic. Alright, so here is writing a standard form of a quadratic. So you will start with the standard form of a quadratic, meaning y equals ax squared plus bx plus c. We're going to fill in each of these parts. So finding a, so to find this a term, it's the second difference divided by 2. Okay, the next one is to find our c value, which that is just the output when the input is x. How we're going to be doing this, and you'll see on this next slide, is we're going to be given some pattern. We're going to go backwards to find what this 0 is, because this is also going to be my c value. Once we have a and c, we can now plug that into this standard equation, and we'll also have a point on the graph because we'll have some number like 1 will be 2 or something. We'll be able to plug in the x value and the y value, and then my a and c that we discovered, and the only thing that's going to be left over is this b value. So we'll be able to find our last value. So let's practice that. Let's see what that would look like. Alright, so we write the quadratic equation from the pattern below. So these are the things we need to find. We need to find a, b, and c, because we're trying to fill in this equation. Ax squared plus bx plus c equals y. Okay, so I told you we were going to start with a table. Remember, we're going to leave that as a 0 because we are going to have to find that 0 term in the sequence. On the first stage, I have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 4, 8, 12, 15, 18. On the second one, I have 18. On the third, 5, 10, 15, 20, 24, 28, 32. Then we have 6, 12, 18, 24, 30, 34, 38, 42. Did I do that right? 1, 2, 3, 4, 5, 6, 12, 18, 24, 30. This is 35, 40, 45, 50. There we go. So there's 50. Okay. So we need to determine if this is quadratic, which means I need to find the second difference, and I totally didn't leave myself enough room. So what I'm going to do is I'm going to write these on a second piece of paper real quick, and then we're going to transpose it to a different slide so we can see a little bit more. So we have 1 8, 2 18, 3 over 32, 4 and 50. Okay. Alright, so I have my x and y table. We're going to recreate this here. 0. I have 1, 2, 3, and 4. 1 is 8. 2 is 18. 3 is 32. And 4, we have 50. Alright, so the first thing is we want to find the first difference. Okay? Which means, what am I doing to get from 8 to 18? Well, I'm adding 10 there. From 18 to 32, I'm adding 14. And from 32 to 50, I'm adding 18. Next, I need to find my second difference. Meaning, what am I doing each time here? So 10 to 14, we are going to add 4. 14 to 18, I'm adding 4. Right here is what tells me I have a quadratic relationship because I have a second difference. So if we have a second difference, the relationship will be quadratic. Okay, so if we remember, to get my a value, I'm going to take the second difference and divide it by 2. That's easy. 4 divided by 2 is 2. To get my c value, I need to find what my output, my y, value is when my input, my x, is equal to 0. So I need to find this missing spot right here. Well, we can go in reverse of what we just did. So to get from here to here, I can subtract 4. So if I'm adding 10 each time, I subtract 4, I should be adding 6 to get from my missing spot to 8. So I just subtract 8 minus 6. That should be 2. Okay, now I just have that b value. So we're going to start with ax squared plus bx plus c. I have a lot of these components now. We'll say equals y. I have a lot of these components. I can pick an x and a y value. We're going to pick 1. We don't want to pick the 0, 2 because that's going to just get rid of everything. That will get rid of my b value. So I'm going to pick 1, 8 as my x and y. And then we're going to insert a and c. So let's put some stuff in here. Alright. So I have a y value. Well, we know what a y is. It's 8 equals my a value, which we're going to say is 2. X squared, well, x we know is a 1, plus, we don't know b yet, but we know that x is 1 from up here, plus my c value, which is 2. Notice we only have one variable now, which is a b value. Okay, now we're just simply going to solve for b. So I get 8 equals, well, 1 squared is just 1. 1 times 2 is 2. Plus b times 1, so that's just plus b plus 2. Now I can combine my like terms. So I get 8 equals 4 plus b. We can subtract 4 from both sides. And I get I'm going to get 8 minus 4 is 4 equals b. So now I know my a is 2, my b is 4, and my c is 2. I now know what the equation is. I can now write this as y equals 2x squared plus 4x plus 2. We just found the standard form of that quadratic. So we said it was 2, 4, and 2. Okay, I want you guys to try now. Find your A, your B, and your C, and use a table to be able to determine something. Alright, hopefully you tried it on your own. Let's do this together. So I'm going to kind of use some space because this problem kind of takes up a little bit of space. I'm going to bring my table over here. Notice I'm going to kind of hug some stuff so I can have room. I do know I'm going to want a 0 at some point. I have 1, 2, and 3. Okay, so 1, I have 5. 2, I have 8. 3, 9, 3, 6, 9. I have 13. Okay. So remember, we're starting with ax squared plus bx plus c. Alright, so a is the second difference divided by 2, so I need to find the second difference. So 5 and 8 is plus 3, and 8 and 13 is plus 5. Is that right? Yeah, plus 5. Okay, so usually we need another term to determine if something's quadratic. I'm telling you to find the quadratic for the pattern below, so I'm kind of telling you it is a quadratic pattern already. Not alright, wow. 3 plus 5 is a plus 2. So there's my second difference. So 2 divided by 2 gives me 1. So I have my a value. My c value, we got to go in reverse, right? So here to here should also be plus 2, which means this would have to be 3 minus 2 is a 1. And then we go to here. So I'd have to go 5 minus 1. And then we'd get a 4. So we have C. So we're good there. Okay. Now let's find our B value. Remember, we're going to use that 1, 5 in our equation. So what we get is we get y, which in this case we're going to say is 5. 5 equals a, which is 1, times x, which is 1 squared, plus b times x, which in this case is 1, plus c, which is 4. Notice once again, the only thing I don't know is my b value. So what we can do now is we can solve for this. I can say 5 equals, well, 1 squared is 1 times 1 is 1, plus b times 1 is just b, plus 4. We're going to combine my like terms here, which is 1 and 4. So we get 5 equals 5 plus b. Subtract that 5 from both sides. And we get 0 is equal to b. And you're thinking, man, why is b 0? It's just how it worked out for this quadratic relationship. So now I can say that this quadratic is y equals 1 times x squared plus 0x plus c. Well, we can simplify this a little bit. We don't write the 1. We're kind of lazy, so we don't have to write that. So I just say x squared. This is nothing, so I'm not going to write anything. Plus 4. There is my quadratic relationship. Alright, that's the end of the lesson. If you have any questions, please feel free to come and talk to me and ask me any questions. Have a great day. Thanks. Bye.